Hey guys, welcome back to ANS Solver. Today we'll be doing the concept of remainder theorem, factor theorem and factorization, which is a subtopic in the chapter of Algebra P2. Okay, so we'll be starting with the concept of remainder theorem. Okay, it's a very easy concept, but once you understand the concept, even factor theorem will be really simple because they are very similar. And we'll even cover the concept of factorization. Okay, so let's start with remainder theorem. A very simple concept. I'll explain you this concept via an example. Okay, so the example is basically, it's a question. So using remainder theorem, find the remainder when 4x cube plus 8x square plus 11x plus 9 is divided by 2x plus 1. Correct? This is basically the question. I know you can even obtain the remainder using full division, but here they have specified that we need to use the remainder theorem, and even in past papers, they specify which method to use. Okay, so now basically what you need to do is I'll write the steps in red so that you're clear. So basically step 1 is really simple. Equate. Okay, we need to equate the divisor. Okay, we need to equate the divisor to 0. Okay, we need to equate the divisor to 0. And we need to solve for x. Okay, really simple step. In this case, I know my divisor is 2x plus 1. Correct? So I can simply do 2x plus 1, which is equal to 0. Correct? So I can simply write this as, now I need to solve for x. So I can write this as 2x equals to negative 1. Correct? So I get my x basically as minus 1 over 2. Correct? Now what I can do is, I can go to step 2. Again, really simple. Okay, plug in or substitute. Plug in this value. Okay, this value for x in the p of x. Correct? So basically what I need to do here is, I know my p of x is 4x cube plus 8x square plus 11x plus 9. So I can simply write this as 4 into minus half the whole cube plus 8 into minus half the whole square plus 11 into minus half, correct, plus 9. Correct? This is what I simply have. So now what you need to do is, you just need to solve this on the calci, and the answer you get is your remainder. So on the calci, what you can do is do 4 into minus half the whole cube, where you simply get minus half. Correct? So you get this as minus half. Then you can simply do 8 into minus half the whole square, which is basically 2. So you get plus 2. Then you do 11 into minus half, where you get minus 11 over 2 plus 9. Now, when you solve this, you basically get your answer as 5. And your 5 is basically the remainder. Correct? So this is basically your answer. Got it? So it's a very simple two-step process. Okay, so the step 1 is basically equate the divisor to 0. Okay, and then you need to solve for x, and to identify the divisor is also easy. Everything after divided by is the divisor. Correct? When you get the value of x, plug it in the p of x, and when you solve for it, the answer you get is your remainder. Correct? This is what you have. Now, what we'll do is, we'll go to the concept of factor theorem. This is really similar to the concept of remainder theorem. Okay, but before that, you need to know the term, okay, of factor. The term factor basically means that your remainder, okay, is always 0. Correct? When divided, your remainder is always 0. That means it's totally divisible. correct? That means the only difference between remainder theorem and factor theorem is your remainder, which you obtain after the full calculation, is always 0, correct? So let's do an example. I've taken an example here. Okay, so the question is basically show that x plus 2 is a factor of x cube plus 3x square plus 3x plus 2 using the factor theorem. So when they are specified factor theorem or remainder theorem, you need to stick to that. You can't use your own method. Okay, you can't use something like full division, correct? So the first step is simple. Take the divisor. In this case, you have x plus 2 and you can equate this to 0. So you get your x basically as minus 2, correct? Now plug this value of x, okay, in the p of x. So you simply get minus 2 the whole cube plus 3 into minus 2 the whole square plus 3 into minus 2 plus 2, correct? Now when you solve this and if you get the answer as 0, that means x plus 2 is a factor. Okay, so let's solve. Minus 2 the whole cube is simply minus 8, correct? 3 into minus 2 the whole square is basically 3 into 4, which is 12, correct? And 3 into minus 2 is basically minus 6 plus 2, correct? So I can write this as minus 8 minus 6 plus 12 plus 2, which is basically minus 14 plus 14, correct? Which is simply 0. That means the 0 here is my remainder, and if 0 is my remainder, that means x plus 2, which I had, okay, is a factor. Got it? This is basically the factor theorem. Really simple, really similar to the remainder theorem. Okay, simple. So now let's do the concept of factorization. Okay, so we'll do this concept in detail when we are doing the past paper examples. I'll explain you the step. But before that, you need to know a very important concept, okay, or a formula. Okay, you know that your dividend, okay, the dividend which you have is equal to the divisor, correct? It's divisor into quotient, correct, plus remainder, correct? This is what you know. Okay, this is a concept. Okay, now, okay, you know that your p of x is always the dividend, correct? Because it comes in the numerator. We had done this in the previous video, correct? So basically you get your formula as p of x is equal to the divisor, okay, into quotient plus the remainder, correct? This is basically the formula which you need to know. A very important concept. Okay, you really need to remember this because this will help you in factorization. Okay, got it? So now let's do some past paper examples. Okay, so the first example is basically testing the remainder and factor theorem, and we'll even do factorization so that I explain you the steps so that you're clear with that concept also. So the first example is from 2019 May-June paper 21. So the polynomials p of x is defined by p of x equals to 5x cube plus ax square plus bx minus 16, where a and b are constants, correct? It is given that x minus 2 is a factor of p of x, correct? That means the remainder here, okay, is equal to 0, correct? And the remainder is 27 when p of x is divided by x plus 1, correct? These are the two sets of information which you have. Now we need to find the values of a and b, correct? You have two variables. That means you'll get something like a simultaneous equation. This is how you need to think, correct? And you have two pieces of information also. So first, let's take x minus 2, correct? That's the divisor, the first divisor. Okay, I know it's a factor, so I can use something like factor theorem. So I can first equate this to 0. I get my x basically as 2. Now I can put this value of x in the p of x. So I simply get 5 into 2 cube plus a into 2 square plus b into 2 minus 16. Correct? And I know this will be equal to the remainder, correct, when divided. And the remainder in this case is 0 as x minus 2 is a factor. So I can simply just equate this to 0 here. Got it? Simple. I'll actually write this on the other side so that it's easy to understand. I'll equate this to 0 here because that's the remainder. So now I simply do 5 into 2 cube, which is basically 5 into 8, which is 40, plus I get 4a plus 2b minus 16, which is equal to 0. Correct? So 40 minus 16, okay, basically gives me 24. So I can write this as 4a plus 2b plus 24 is equal to 0. So I simply get 4a plus 2b, which is equal to minus 24. Correct? So this is the one equation which I get. The first equation for the simultaneous. Got it? From the first set of information. Now I know that the remainder is 27 when p of x is divided by x plus 1, which is the second divisor. So I can simply write x plus 1 equals to 0. So I get my x basically as negative 1. Now I can substitute this. So I simply get 5 into negative 1, the whole cube, plus a into negative 1, the whole square, plus b into negative 1 minus 16, which I can equate it to the remainder, which I know in this case is plus 27, positive 27. So I simply write 27 here. Now 5 into minus 1, the whole cube is minus 5, correct, plus a minus b minus 16, which is equal to 27. Correct? So now I can simply write this as minus 5 minus 16. Correct? Which is minus 21. So I can write this as a minus b minus 21, which is equal to 27. So I can write this as a minus b equals to, when I take 21 to that side, I get 27, okay, plus 21, which is basically 48. Correct? This is what I get. So I can simply say that this is my equation number 2. Now the two equations I have is simply 4a plus 2b equals to minus 24, and I have a minus b equals to 48. As you can see, this is a simultaneous equation, correct, which I have here. For this, what I can do is I can simply use my calc. Okay, it's a really simple method. It will be a very fast method. Okay, so this is basically for simultaneous equations. Okay, so remember, what you can do is on the calc, first click on mode. When you click on mode, click on 5 where equation is written. Once you click on 5, you can click on 1 for simultaneous. When you do that, you basically get 6 coefficient boxes. Something like this. Correct? 3 on top, 3 in the bottom. Okay, these are called coefficient boxes. So in the first coefficient box, put the coefficient of a, which is 4. So simply write 4 here. Then the coefficient of b, which is 2. Then the constant, which is minus 24. Correct? This is what you simply put. Then put the coefficient of a, which is 1. Then the coefficient of b, which is minus 1. And then you put 48, which is the constant. So when you put 4 equals to 2 equals to minus 24 equals to 1 equals to minus 1 equals to 48, and you click on equal to after that, you get your x, which is basically a, as normally in a simultaneous it's always x and y here. But in this case my x is a and my y is b. Correct? So I can simply write my a, which is equal to 12, and my b, okay, which is equal to minus 36. This is what I get. Okay, so I can simply write my final answer as A equals to 12 and B equals to minus 36. Correct? So really simple question. You straight away get 5 marks, in your pocket by doing this much. Correct? The basic use of remainder and factor theorem. Okay. Now part 2 is important because this is the concept of factorization. Okay. So hence factorize P of X completely. So the step 1, you need to, listen to me carefully. Okay, you need to write your P of X something like the quotient into the divisor. I'll write divisor in full so that you're not confused. Plus the remainder. Correct? This is how you need to write the P of X. But first, I know I have the divisor, I have my remainder, but I don't have my quotient. So first, you need to obtain the quotient, for which you can simply use full division. Correct? Because in that method, you always get the quotient. So you write the divisor. Okay, let's say the divisor, in this case, you can either take x minus 2 or x plus 1. Take it as x minus 2 as you're factorizing, and you know x minus 2 is a factor. So write x minus 2 simply. Correct? When you write x minus 2, okay. Now write the P of X. So write 5x cube. Okay. You get 5x cube. Okay. Plus 12x square because your A is 12. Correct? Minus 36x minus 16. Correct? I just substituted the values of A and B in the P of X which I have here. Correct? So now I can attempt full division. We've learned this, okay, but I'll explain it to you again properly. Okay, so in full division, basically, I need a 5x cube here. Correct? So what should I multiply to x to get a 5x cube? I can simply multiply it by 5x square because x into 5x square gives me 5x cube. Correct? Then I can simply do minus 2 into 5x square, which basically gives me minus 10x square. Now, what I can simply do is, I can multiply this full thing here by negative. Correct? This is what I can simply multiply this by. And I can get minus 36x minus 16 down. So when I take the negative inside the bracket here, I get negative 5x cube. That means this full thing will get cancelled as 5x cube minus 5x cube is 0. Then I can take the negative here and the negative here, which will become positive. So I simply get 12x square plus 10 plus 10x square, which basically gives me 22x square minus 36x minus 16. Now, I basically need a 22x square. So what should I multiply to x to get a 22x square? I can simply multiply it by plus 22x. Correct? Because x into 22x is 22x square. And minus 2 plus 22x is basically minus 44x. Correct? This is what I get. Now what I can simply do is, I can multiply this full thing by negative. Got it? Now when I multiply this full thing by negative, okay, the negative and positive here becomes negative. So I get 22x square minus 22x square. So this thing cancels out. I have a negative here and negative here. So it becomes positive. So I get 36x plus 44x, which gives me 8x. So I get 8x minus 16. Now what should I multiply to x here to get an 8x? Correct? I basically need an 8x here. I can simply just multiply this to 8. And negative 2 into 8 will give me negative 16. So I simply get negative 16. Now what I can simply do is, I can multiply this full thing by negative. When I do that, I get my answer basically as 0, which is justified as I know x minus 2 is a factor. But now I've got the quotient which I needed. So I can write my P of x, okay, basically as the quotient, which is basically 5x square plus 22x plus 8. correct, which is multiplied by the divisor, in this case which is x minus 2, plus the remainder, which is 0, as it's a factor. Now what I always do is I equate this to 0. So I get 0, which is equal to 5x square plus 22x plus 8, correct, into x minus 2. Okay, it's okay if you don't write plus 0. Now I know I can write this as 5x square plus 22x plus 8, which is equal to 0. And I can write this as x minus 2 equals to 0. Okay, so I leave the x minus 2 as it is because I know it's a factor already. Correct? I focus on the quadratic, okay, which I have. It's a really important quadratic. So for this, what I can do is I can simply use the calci. Okay, so on the calci, I can go to mode. When I click on mode, I can click on 5 where equation is written. And once I click on 5, I can click on 3 because 3 is for quadratic. Like here, we had 1 for simultaneous. We have 3 for quadratic. Correct? So when I do mode 5 and 3, I basically get 3 big coefficient boxes. Correct? Okay. In the first box, what I do is I put the coefficient of x square, which is 5. In the second box, I put the coefficient of x, which is 22. And in the last box, I can put the constant, which is 8. So when I put 5, okay, equals to 22 equals to 8. Correct? When I do that, I basically get two values of x. I get my x basically as minus 2 over 5. And I get my x basically as minus 4. Okay? Now, you need to listen to the steps very carefully. It's really simple. We've done 99%. Okay, but how do I write this in this form like a factor? Okay, very simple. First, take this 5 to the other side here. Okay, so you can write this as 5x equals to minus 2. This is what you do, for the fractions. Okay, now take the negative 2 to the other side. So you basically get 5x plus 2 equals to 0. So you can simply just write this as 5x plus 2. Correct? Now, what you do is, here you have minus 4, so it's really simple. It's not a fraction. So you can simply just write this as x plus 4 equals to 0. So you basically get x plus 4. Correct? So now you have three things here. Correct? So you can simply write the factors as 5x plus 2 into x plus 4 into x minus 2. Okay, these are basically the factors, and this is how you completely factorize the p of x. Okay, really simple. So I'll again, go over the steps. So for factorization, basically you need to write a p of x, okay, in the quotient into divisor plus remainder form. Okay, in some sums, you already have your quotient, so you don't need to attempt long division all over again. You can simply write, okay, you can simply go to this step here. But if you don't have your quotient, you can, attempt full division, obtain your quotient, then write this into the p of x form. Okay, normally your remainder is always 0. So you can equate this to 0. So you get your quadratic equals to 0 and the divisor equals to 0. Okay, as your remainder is 0, your divisor is already a factor. And for the quadratic, you can simply do, mode 5 and 3. Then, input the coefficients, get the values of x. Okay, if it's a fraction, first take the denominator to the other side, then take the numerator. Okay, like I did it in the sum. Okay, and then you simply get your three factors. And you should always know that your quadratic equation gives two factors. Okay, it basically always gives two factors. Okay, this is what you need to know. And then you can simply factorize your p of x. Okay, but okay, this is basically the standard, the standard procedure which you need to follow. But they can trick you in some places, which we'll do in the next past paper example here. Okay, so listen to that also very carefully. So this past paper example is basically from 2019, October-November, paper 21, question 4. Okay, the polynomial p of x is defined by p of x, which is equal to ax cube plus ax square minus 15x minus 18, where a is a constant. Okay, and it is given that x minus 2 is a factor of p of x. Okay, factor basically means that my remainder is equal to 0. Correct? So I basically need to find the value of a here. Correct? So I can simply write this as x minus 2, which is equal to 0 first. So I get my x as 2. Correct? Now I can plug in this value of x in the p of x. So I get a into, sorry, not minus 2, a into 2 cube plus a into 2 square minus 15 into 2 minus 18. Now I know I'll equate this to the remainder which I have. In this case, I know x minus 2 is a factor, so my remainder is 0. So I write 0 here. Correct? Now 2 cube is basically 8. So I get 8a plus 2 square is basically 4. So I get 4a, and minus 15 into 2 is basically minus 30 minus 18, which is equal to 0. So I can do 8a plus 4a, which gives me 12a. And here I get minus 48, which is equal to 0. So I can write this as 12a, which is equal to 48. So I get my a here basically as 48 over 12. So I get my a, which is basically equal to 4. Correct? So this is how I obtain the value of a. There are many more sums in the past papers where they have asked questions like these. Okay, so let's move on to part 2. Okay, so now using this value of a, factorize p of x completely. Another factorization question. Okay, so that we are 100% sure with this concept and have a perfect grip on this. So first, I need to write my p of x, okay, in the quotient into divisor, correct, plus remainder form. But here again, we don't have a quotient, so I know I need to perform long division first. Okay, so I write the p of x which I have. So the p of x, okay, with a, okay, this is the p of x which I have. So with a, what I can do is I can simply write this as, I know my a is 4. So I can write this as 4x cube, okay, plus 4x square, okay, minus 15x, okay, minus 18. Correct? This is how I can simply write it. Okay, and I know my divisor here in this case is x minus 2. So what I can do is I can write x minus 2 here. Now simple long division. Okay, so I need 4x cube here. So what should I multiply to x to get a 4x cube? I can simply multiply it by 4x square. Now I do minus 2 into 4x square. Minus 2 into 4x square is minus 8x square. So I can write this as minus 8x square. Okay, and I can multiply this full thing by negative. Now what I can simply do is I can get minus 15x minus 18 down. So I write minus 15x minus 18 here. When I take the negative inside the bracket here, I get 4x cube minus 4x cube, which cancels out to be 0. The negative and negative here becomes positive. So I get 4x square plus 8x square, which is 12x square. Okay, now I basically need a 12x square here. So what should I multiply to x to get a 12x square? Simple 12x, because x into 12x is 12x square, and minus 2 into 12x gives me minus 24x. Now what I can do is I can simply multiply this full thing by negative, and I can get minus 18 down. Now I have negative and positive here, so this becomes negative. So 12x square minus 12x square is 0. So this cancels out. I have negative and negative here, so I get negative 15x plus 24x, which gives me 9x. So I can simply just write this as 9x here, because negative 15x plus 24x gives me 9x. Okay, minus 18. Now I need a 9x here. So what should I multiply to x to get a 9x? I can simply multiply it to 9. And minus 2 into 9 is minus 18. When I multiply this full thing by negative, I get my answer 0, as everything cancels out. And it is justified, as I know x minus 2 is a factor. Correct? So now we've obtained the quotient. So I can simply write my p of x as the quotient, which is 4x square plus 12x plus 9, which is multiplied by the divisor, which is x minus 2, plus the remainder, which is 0. Okay, simple, substitution of this formula, which I've done. Now the next step is I equate this to 0, so I write this as 0 equals to 4x square plus 12x plus 9 into x minus 2. So I can write this basically as 4x square plus 12x plus 9, which is equal to 0. And I get x minus 2 equals to 0. I know x minus 2 is a factor, so I'll just write this as x minus 2. Now we'll focus on this quadratic. This is 9, just in case it looks like a 4. Okay, so now what the process of calculating a quadratic, I'll write it down again. Okay, so on the calci, what you need to do is you need to go to mode. When you go to mode, you need to click on 5 where equation is written, and when you click on 5, you need to click on 3. So you simply get 3 coefficient boxes. Okay, you simply get 3 coefficient boxes. In the first box, put the coefficient of x square, which is 4. In the second box, put the coefficient of x, which is 12. And in the last box, put the constant, which is 9. So when you simply put 4, 12 and 9, okay, you basically get one answer. Okay, you only get one x, which is equal to minus 3 by 2. Okay, here the concept which you need to know is that the quadratic, okay, always gives you two answers, two roots. But here you have only got x equals to minus 3 over 2. Okay, so while you factorize, what you do is you write this as x equals to minus 3 over 2 and x equals to minus 3 over 2. Write it twice, okay, as you can get, two roots, okay, because the quadratic always gives two roots. Okay, so if you only get one root, what you simply do is you write it twice, something like this. Now, what you do is you can simply first take the denominator here to the other side. So you get 2x equals to minus 3. Here also you get 2x equals to minus 3. Correct? Then take the 3 to the other side. So you get 2x plus 3 equals to 0. And 2x plus 3 equals to 0. Now you can simply just write this as 2x plus 3 into 2x plus 3. Correct? Multiplied by the x minus 2 which you have, which is a factor. Correct? This is what you can write it as. So now, because both of these are same, you can multiply this and write this as 2x plus 3 the whole square into x minus 2, which is basically your final answer. So this was one type of trick which they normally ask, okay, where they give you a quadratic and you only get one root. So you write it as two roots like this, okay, and then you square it, something like this, okay. Or normally, like 90% of the times, you get a question, basically something like this, which we discussed here. Okay, you basically get two roots and then you write your answer something like this. Okay, but in case you get one root, don't forget to square it here, write it something like this. Okay, or else they'll cut 1 mark. Okay, so this is very important to know. Okay, so this was basically the concept of factorization. Okay, and with this we come to the end of the chapter of modulus and polynomials. Okay, so I hope you enjoyed the chapter a lot, but the thing is, only knowing these concepts and doing this few past paper examples won't help. You need to do more topic wise past paper examples which we provide, and obviously you will get stuck because it's not that easy. Okay, because there are many different type of questions which they ask. Okay, so in case you get stuck, we provide the video and pictorial solutions. So the video and pictorial solutions we provide, please have a very good look at it. Okay,